Paper 1, question 17. Samit has a pond in the shape of a prism, okay? That there is the prism that they've got in the drawing. The only difference is instead of those dashed lines that they've put there, I've kind of got this sort of peachy colour, faint so you can just see it, alright? Those represent the edges of the prism that are behind. The blue ones are behind these faces at the front, so you wouldn't actually see them. So just the blue bits are what you would see at the front, okay? Like so, alright? So if you were to look at it, that's what you would see. Now, based on that, some people I spoke to about this question struggle to kind of actually visualize where this prism had the two faces, you know, the front and the back, and then you've kind of got a body, a length to it. Well, the face itself is actually this front bit. That front bit is the face, and this depth diagonally into the page is the length, okay? So at the back, this side on the front here and this side on the front there, that is the front face, and at the back you would have the back face, and they're identical in size, okay? Usually when they present a question like this involving a prism in an exam, the diagonal sort of slope lines, they represent the depth, okay? So imagine it's kind of either coming out here at the page or going into the page, okay? These are all the values that have been given to you. It says the pond is completely full of water. So in other words, that prism is full of volume. Its volume is full. Samit wants to empty the pond so he can clean it. Samit uses a pump to empty the pond. So pond is full of water. If you're emptying it and pumping water out, the level of it is going to drop and drop and drop and drop and drop until it's empty. The volume of water in the pond decreases at a constant rate. So that means the rate at which it falls, or the rate at which volume is removed, would be constant. The level of the water in the pond goes down by 20 centimetres in the first 30 minutes. Now, given that this is the height, which is 0.5 metres, the water level is going to go down the way. So that, and of course the 1.3 over here, that we had over here, those are the values that we're concerned with in terms of this falling rate. 0.5 metres just being 50 centimetres. Now, it said that it had fallen 20 centimetres in the first 30 minutes. So, in other words, if you've got this bit as being 50 centimetres, there, and then this one as being 1.3, and of course you had your peachy bit at the back, it's going to have fallen to about here. So the water level itself would probably be somewhere like that. So everything above that pink line, the water that used to be there is now not there, okay? And what that does is, if I put in the three-dimensional bit here, and then there's the water level at the back, everything above that pink line is a cuboid in itself, okay? So even though it says the water level has gone down by 20 centimetres, you can figure out how much volume of water has been removed based on that. And that'll tell you how much has gone in half an hour. So that's what we do to begin with. You find out how much water has gone. So the volume of, I'll label it here, water removed. The volume of a cuboid is length times breadth times height. So if I go right back to the beginning, the first thing I mention is our height here is going to be 0.2 meters. Our values here for the length and breadth of this cuboid are 2 and 1. So we have 2 times 1 times 0.2. So 2 times 1 times 0.2, and that's going to give us 0.4. They're all those measurements are in terms of meters, and it's important to note that that 20 centimeters I changed into meters, otherwise I wouldn't be able to use it along with those. I could have turned those into centimeters if I wanted, so I had 200 and 100. I've simply chose to do it this way because the numbers you have are easier. So that's in cubic meters, and that's 30 minutes worth of pumping, basically. So 0.4 meters cubed is the equivalent of 30 minutes of water removal, okay? Work out how much more time Samit has to wait for the pump to empty the pond completely. So There's a little twist to that question that some might miss out on. If we want to find out how much more time it takes to empty the pond, we're going to have to find out how much volume there is left over to empty. And in order to do that, what we do is we find the volume of the whole pond and take that away. Okay, so that's the first thing we're going to do there. Find the volume of the whole pond and take it away. So, given the fact that this is the face of a prism, and the volume of the prism is the area of the face times its length, that's exactly what we need to do. We need to use the area of the face and multiply it by its length. The length in this case is 1, so when it comes to it, this times by the length bit, this times by 1 bit, isn't going to change anything. The real meat of this question is the area of the face. So we have 1.3 is this height, 0.5 is that height, and 2 across the way. We can add that to our picture here, if I just move that over a little bit. So we have 0.5 here, 2 meters here, and 1.3 meters here. Okay. For the really clever cookies, you're going to use the formula for the area of a trapezium and go ahead and do that. But for the vast majority of us, and I include myself in this, I would break that up into 2 shapes because I would treat that as a composite shape. As in the shape that when you look at it instinctively, you wouldn't name it. You wouldn't know the name of it. So I'm going to break that into 2 pieces. So you've got a rectangle and a right angle triangle. The area of the rectangle is length times breadth, so I'm going to have 2 times 0.5, which equals 1 meter cubed. Sorry, not meter cubed, meters squared, because it's area. I should highlight that's the area of the rectangle. The area of the triangle is going to be half of the base times height. So this here would be the height. The difference between 1.3 and 0.5 will leave me with a 0.8 meters. So it's going to be half of 0.8 times 2. The half of and the times 2 are technically going to cancel each other out, and that will leave us with 0.8 meters squared. So if we want a total for the area of all of those, the rectangle and the triangle, we add them together. We've got this 1, we've got this 0.8. The area of that trapezium is going to equal, it's not a very good picture, it's going to equal 1.8 meters squared. Multiply that by this length of 1 to give you the volume of the prism. That 1.8 hasn't changed, but now we have the volume of the pool in total, okay, 1.8. So the volume that's gone, or in other words, after 30 minutes, the volume that had disappeared was 0.4. And we're looking for how long it takes to get rid of the rest of the volume. Now, 1.8 was the full tank, that's already gone. So we need to find the difference to determine how much volume is left to get rid of, okay? And what you're left with here is a simple direct proportion problem, okay? The longer you spend removing the water from the pond, the more water will be removed from the pond. The less time you take, the less water will get removed. So what you have to do is find a number that either multiplies direct or find a number that goes into both of these so that you can do a division and then a multiplication to go from that number to that number. Now, 1 always works out nicely for any form by the unitary method. A value I'll pick, which is a lot nicer, is 0.2. Okay? This is where your highest common factor scales kick in quite a lot. 0.2 goes into that nicely because that's twice as much, and 0.2 goes into 1.4 nicely, it's 7 times as much. So if I am going to turn a 0.4 into a 0.2, and then a 0.2 into a 1.4, I'm going to divide by 2, and then I'm going to times by 7. Alright, I'm going to half it, then I'm going to times it by 7. If I do the same with this, divide by 2, that's going to give me 15 minutes. Should do this in blue. 15 minutes to get rid of 0.2 meters cubed. And then multiplying that by 7, what I end up with here is 105 minutes. Or 1 hour and 45 minutes. That's how long it's going to take you to get rid of the rest of this film.